All right, the category today is solving quadratic equations by completing the square. Solving quadratics by completing the square. I'm going to try to get you some book here, and just so that in case I forget to do it later on, here's some problems that we're going to do. First thing I want you to know is we're solving the same problem that we've been solving the last few days, okay? Last time we did by factoring, so we could put parentheses, and try to factor this, see if it factors, and we could solve it that way. Or we could fire up our calculator. We could set this equal to y, set y equals to this, put it in our calculator, and look for the places where the graph crosses the x-axis, because when it crosses the x-axis, that's when y is equal to 0, all right? So we have it equal to 0, and that's the first step in solving here once again. But we're going to solve by completing the square. So watch carefully the steps in completing the square. It's just like baking a cake and doing the recipe. You take this much of this, you take this much of this, then you do this, then you do this. There's not that many decisions that you have to make. You just have to go through the steps. The first step is make sure you have it equal to 0. Get it in descending order like this, right? X squared, something x, and then something. All right? And then the next thing to do is to move this number over there and create yourself a space. So let's do that. Subtract, in this case, add 20 to both sides. X squared plus 8x equals 20. Because what we want to do, we want to add 20 to both sides. We want to leave this space right here because we want to put the number that we want in there that will make this into a perfect square trinomial. Now what I mean by perfect square trinomial is we want it to be some that we could take it as a binomial squared. In other words, the same binomial times itself. And here's how you do it. So create that space right here. You come to this, if this number's 1 right here, this 1x squared. You look at this and you say, take half of this and square it. Half of 8, okay, this is a positive 8. Half of 8 is 4. 4 squared is 16. So the number that you want right here is 16. Now, you can't just put a plus 16 right there without putting a plus 16 over here, so you have to add it to both sides. The reason that we chose 16 is because now I know that I can factor this into x plus 4 quantity squared, right? If we were factoring this and I had this right here, you would say, okay, it's got to be x times x to give me x squared. The signs have to be the same, both positive, so you go plus and plus. Two numbers multiply to give you 16 and add to give me 8, and you say, oh, that's 4 and 4, right? So it factors into x plus 4 times x plus 4. We knew it would factor into x plus 4 squared because we specially chose this number by taking half of this and then squaring it and putting it right there. And then what we get down here is going to be x plus whatever we had when we took half of it. So x plus 4 squared is what that comes out to be there, okay? So now, all right, so the problem is about half work, so that's the first part of it. The next thing to do, once you get this, don't forget to add the 16 over there also. X plus 4 squared is equal to 36. Now this is a problem that we're going to be able to solve because we can just go back to find out what's happening to the variable and do the opposite. 4 is being added to it and the whole thing is being squared. So if you want to undo the whole thing being squared, you have to take the square root of both sides. So take the square root of both sides. Whenever you do, you take plus or minus the square root over there. All right? And so the square root of something squared is just this x plus 4. So you've gotten rid of the squared now by taking the square root. Of course, the square root of 36 is 6, but it's plus or minus 6. Okay? So that's 2. You've got two answers. X plus 4 equals 6, or x plus 4 equals negative 6. And then solve each one of those. Subtract 4 from both sides, and you get 2. Or when you subtract 4 from negative 6, you get negative 10. Keep in mind in all of these, where the instructions were to solve the equation, what you're looking for, the answer you're looking for should be in solution set, some number right there, okay? So the ones that you did by graphing, you should have shown me the graph. Here's the graph, and then show me the 2 points where it crosses the x-axis, and then say, here's my answers, boom, negative 10 and 2. If you did solve this by factoring, you should have said, okay, I should be able to look and say, oh, there's the factors, and it would be like x plus 10 and x minus 2. My answers are negative 10 and 2. The solution set is what you're ultimately looking for, the answers that would solve, that would make this a true statement. Again, what we're looking for is any number you can put in for x and make it a true statement. If you put in a 2 right here, 2 squared plus 8 times 2 minus 20, that would come out to be 0. So that's failed. That's not a fail, it's a pass. Okay, so solving this one right here by the same token, okay? So first thing we do, get rid of the 11. So we create a space for ourselves. So we got 4x here. You have to subtract 11 from both sides. Create that space over there, because in there you're going to want to put your special number. The number that you get is going to be, take half of 4 and then square it. 2 squared is 4, so you want to add 4 to both sides. The reason that we chose 4 is because we knew that once we did that, it would factor into x plus 2 times x plus 2, or x plus 2 squared. Anytime you put the right number in there, it's going to be able to factor into some binomial squared. And the good thing about this is, now you have something that you can solve. Now you can just say, hey, find out what's happening to the variable, do the opposite. 2 is being added, the whole thing's being squared. Start out by taking the square root of the whole thing. When you do, you take plus or minus the square root of this side over here. Okay, and now, see, this one I have was a pretty one over here, right? It came out the square root of 36, and you just said, oh, that's 6, so you just have plus or minus 6. Now I have the square root of negative 7, which is more of a problem. But because we did imaginary numbers not too long ago, you know what to do with that. That just means take out an I, and you're still good. X plus 2 is equal to, so what it means is I times the square root of 7. Or x plus 2 equals negative I times the square root of 7. Okay, so when you take the square root of both sides, be sure you take plus or minus, because you get both of those answers. So you just take out the square root of negative 7 is the square root of negative 1 times the square root of 7. I times the square root of 7. Alright, and now subtract 2 from both sides. So go negative 2 plus I times the square root of 7, or x equals negative 2 minus I times the square root of 7. And that's what you're going to put in solution set. Negative 2, and you can just put them together, plus or minus I times the square root of 7. So there's the two answers. Again, the system says just subtract 11 from both sides. Once you create that space, take half of this and square it. Whatever that b is, you know, ax squared plus bx plus c, whatever b is, take half of that and then square that number. That's what you want to add to both sides. Then it factors into x plus whatever you have when you took half of it, and then you go ahead and solve it from there. Okay, that's completing the square. So the book does a good job when you look at the problems there that I showed you, which I'm going to show you again, just to make sure that you have these, right? You got that page like that. So on this page like that, the problems that you're doing, number 14 through 21, it says solve the equation by using the square root property, okay? So what it is they've already completed the square for you. They've already given you a perfect square trinomial. So that all you have to do is finish this now by saying, oh, okay, x squared plus 4x plus 4, that factors into x plus 2 squared. So for all of those problems, like I said, the book does a good job of breaking it down. For all of these problems, it'll already be a perfect square. You just go ahead and finish it. So that's equal to 25. Take the square root of both sides. Be sure to take plus or minus. Okay, so the square root of 25 is going to be 5. So x plus 2 is equal to plus or minus 5. All right, so that means x plus 2 is equal to 5, or x plus 2 equals negative 5. And subtract 2 from both sides, you get 3. Subtract 2 from both sides, you get negative 7. Okay, so this problem starts out with it's already solved for you. All right, look at the next set of problems. So the next set of problems toward the top here, there you go. These are the beginning of the problem, okay? So now all these problems, number 24 and following, are saying, okay, what would you like to put in here to make it into a perfect square? And it's just giving you the practice of taking half of 16, which is 8, squaring it, and it's 64. So you just, right now it has a c in there. What would c have to be to make it a perfect square trinomial? Okay, and that's all you have to do is just say that that's 64. You don't even go x plus 8 squared and all that. There's no problem to finish. It's just this part of it. Okay, and then the next one, the next section is doing the whole thing. Okay, so one more time, solving by completing the square. So what would you do with this? You would take 15 and get it over there. X squared minus 8x equals negative 15, because you have to subtract it from both sides. Leave yourself a space right there so you can put in the number you want to make it into a perfect square. Take half of negative 8 negative 4. Square that, 16. Add 16 to both sides, because 16 is the number that would make this into a perfect square trinomial, meaning it's going to factor into some binomial squared. All right? So what would it be? What's going to go in here? Well, it's going to be x, and it's going to be whatever you had when you took half of that. And if you don't believe me, you can just check this by taking x minus 4 times x minus 4 and making sure that it does come out to be x squared minus 8x plus 16. Okay, so it factors into x minus 4 squared. This one just happens to come out nice over there, because when we take the square root of both sides, the square root of 1 is 1, so that's good. Gets rid of the square root, gets rid of the square there, so that's equal to plus or minus 1. Add 4 to both sides, so 4 plus 1 is 5, and 4 plus negative 1 is 3. Solution set is 3, 5. And once again, if you just, it's a good idea, since you've got your calculators, you want to check those, firing up the graph